Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right up there. I'm not sure how I'm going to tell this, but I'm going to tell this how I tell it in the title. But what I am sure of is our one goal today. And we're joined by a cricket that just won't stop cricketing. Our first and only goal is solving one-step equations using division or multiplication and checking. The main idea is to use division to undo multiplication and to use multiplication to undo division. So I'd like to give a couple examples of what each operation looks like. So examples of what multiplication will look like. 3 next to an x, nothing between it. Negative 5 next to a y, nothing between it. Or a negative x. These are all examples of multiplication. Alright, and in order to solve, I have to use division. And division will look like a variable x divided by 2 with a line between them, y with a line over 5. That's what they're going to look like. Since we're dealing with multiplication and division, we do have to understand our sign rules. We have 8 of them, but there's actually 4. A positive and a positive. Positive times a positive is a positive. Positive times a negative is a negative. A negative times a positive is a negative. A negative times a negative is a negative. Positive divided by a positive is a positive. A positive divided by a negative is a negative. A negative divided by a positive is a negative. And a negative divided by a negative is a positive. Alright, that's what we need to achieve our goals. So let's just jump right in and solve these things. I have 3 examples of multiplication problems that need to be solved by division. And I have 3 examples of division problems that need to be solved by multiplication. I'm going to do this. I'm going to make that a -3. Just a wild card. Okay. Alright, so let's go ahead and jump right in. I have multiplication, so I have to undo multiplication by division. And so what I'm going to do is draw a line under the 4x, put a 4, and draw a line under the 8 and put a 4. These are going to divide each other out. They're actually going to become 1. And you're going to get 1 times x, which is just x. But we can just cancel them out and say x is equal to 4 goes into 8 2 times. So now I need to check these. Okay? And what I'm going to do to check is I'm going to write the original equation, which was 4, but I'm not going to write an x. I'm going to put the number in place of the x and write that as an 8. Actually, I'll just write it like this. Let's do it. We'll say 4x equals 8. I'm going to replace the x with a 2. Okay, and I haven't finished simplifying, so I got to put these together. 4 2's is 8. 8 equals 8. That's a true statement, and I have a solution. So that is an answer to that multiplication problem, and I solved it using division. Okay. Oh, and by the way, I had a positive divided by a positive, so I had to get a positive. Problem number 2. Negative 2x times, negative 2 times x equals negative 6. I need to divide away the negative 2 so I can get the x by itself. Now, many students will just divide away a 2, but that's not the number that's with the x. We have to divide away a negative 2. Alright? And so the negative 2's cancel on the left. I have a negative being divided by a negative. So I know my answer is going to be positive, and negative 2 goes into negative 6 3 times. Okay. So again, whatever number is next to the variable, I put it underneath every other number. Let's go ahead and check this. So here I have minus 2x equals minus 6, and then we get minus 2. I'm going to replace the x with its value of 3. And that's equal to negative 6. Here I have a negative times a positive. So I have this situation, so my answer is going to be a negative. Negative 2 3's becomes a negative 6, and negative 6 equals negative 6. That is true. Alright. I was going to ask if there's any questions, but there's no one in here. Problem number 3. Now, problem number 3 is a little tricky because it says negative x. We don't necessarily see the number that's there, but this is actually negative 1x equals to 9. So again, I have multiplication like I had in the prior two problems, and I need to use division to solve it. Alright, we're using the opposite operation, or we're undoing. So again, whatever number is right next to the x, that is the number that I'm going to divide away. Alright, so here we go. These numbers divide each other, they cancel out, and that means that x is equal to, well, I got a negative dividing into a positive, so I know my answer will be negative. And I can put -1 into 9, -9 times. I need to now check this. Alright, so again, I'm going to write my original equation. I have negative x equals to positive 9. Again, I replace the x with a parenthesis, so it becomes negative. And I'm going to put a -9 in there, and that equals to 9. Now again, I have a negative and a negative. And I know that that's going to make a negative times a negative is a positive. Oh my gosh, so embarrassing. A negative times a negative is a positive, so this is going to become 9 equals to 9. Alright, and again, that is true. Oh, I can't believe I made that mistake. A negative times a negative is a positive. Are these all rest of these right? I better learn this. Oh my gosh. It's like 6 in the morning. Let's move on to problem 4. Here I have division. And to undo division, I need to use multiplication. So division, undo multiplication, we saw that in the first three. And we're going to use multiplication to undo division. Ultimately, we're going to make these three problems look like those, where I have the same number below and above the fraction, and then that allows me to cancel them out. So problem number 4, I'm dividing x by 2. So that means if I multiply x by 2, I've created the same situation that I've created on the other problems, and I can just cancel this out. It's really easy to cancel out fractions in equations. So now I have positive 3 times positive 2, that's going to give me a positive 6. Right? That's going to give me a positive 6. I've solved it again because x is by itself, and so what I'm going to do is I'm going to check, and I always check in the original, and here I have x over 2 is equal to 3. I now can replace my x with a 6, because that's what we agreed that x is going to be. I'm going to replace it out. 2 goes into 6 3 times. So we're going to get 3 equals 3, and that is true. So again, I want to point out, all I have to do is multiply everybody by what the denominator is, and I cancel it out just like I did in the previous problems, and the fractions are gone. Alright? Problem number 5. My number in the denominator is -3. It's dividing x. So to undo division, I need to do multiplication. So I'm going to write a -3 up top, and I'm going to write a -3 on the side. I can put parentheses around either one. That's probably the habit we should get into. So here I have a -3 below, a -3 up top, and just like all the prior problems, and the numbers, same numbers above itself, we can cancel it out. And let's see here, x is going to equal, and I now know that a negative times a negative is a positive. Oh, that was so bad. Negative times a negative is a positive, so -4 times -3 is going to get me to positive 12. So now that I've got x by itself, I can now check. And again, I always check in the original problem. And my original problem was x divided by -3, and that was equal to -4. Again, everywhere I have the x, I'll replace it with this value. And I have a positive being divided by a negative, so I know my answer will be negative, so this is going to become negative. -3 goes into 12, -4 times, and -4 equals to -4, and again, that is true. The last problem, and I wish I would have had one more problem. I'll explain why here in a second. The last problem. 5 equals x over 2. Now, this problem, I have the x on the right side, and I'm looking at this, and I should have had the x on the right side in the first 3 problems, but I can explain that away real quick. Alright, but the idea doesn't change. X is being divided by 2, so that means I need to multiply everybody by 2, because multiplication undoes division. So what I'm going to do is I'm just going to put a 2 next to every number, And now that I have a 2 above and a 2 below, I can cancel out the 2's. And now I have 2 times 5, which is going to give me 10. 10 is equal to x. Now I need to check this. So I'll write my original equation, 5 equals x over 2. I know that my x can be replaced with a 10, so 5 equals 10 over 2. 2 can go into 10 5 times, so that means that we're going to get 5 equals 5, and that is true. Alright, so the thing I wanted to say that I just realized that I left out, and I'll do one more problem. I'll make up problem number 7. And I just want to show something really quick. We'll say 15 equals 3x. This is a multiplication problem. That means I need to undo the multiplication by division. Now what makes this problem different than the first 3 multiplication problems is the variables on the right side. But you still do what we've been doing, is we divide away the number next to the variable. Alright? So the idea doesn't change, and I'm going to get 5 is equal to x. And again, I need to check. This cricket will not stop. So I write my original equation, 15 equals 3x. And then I replace my x with the value that I got. Make sure I put a parenthesis around it. 3 5s is 15. And 15 equals 15, and that is true. Alright, so I'm going to go ahead and end this second lesson in solving one-step equations using multiplication or division and checking. And remember, the main idea, use division to undo multiplication and use multiplication to undo division. I have multiplication if the number is right next to the variable, nothing between it. I have division if I have a fraction. And if I have division, I have to use multiplication. Alright, I'm going to go ahead and end this here. Again, I hope everybody is doing alright out there. Have a great day, everybody. Bye-bye.